Yeah, thanks for the short introduction. I'm Siegfried, and today I will give a different talk. Basically, it's on security, and I'm super happy that so many guys are interested in security, and especially in Android security. Today I will talk about our new tool in our research. It's called CodeInspect, and it's a reverse engineering tool. So we will see. I guess the community doesn't know me, so I will introduce myself a bit. I'm a third-year PhD student at the TU Darmstadt in Germany. It's headed by Eric Bodden, and our research group is mainly focusing on developing a static and dynamic code analysis approaches for security reasons, for instance, for automatically detecting vulnerabilities in programs or apps. And my main research focus is on Android, so on the security on Android, and especially on, as I already mentioned, static and dynamic code analysis Android in order to identify malicious applications or vulnerabilities, for instance. A few words about the stuff what we did so far. We found 2 AOSP exploits. So this means vulnerabilities in the AOSP which got reported to the Android security team. One got fixed in 4.4, I guess, and the other one is unfortunately not fixed yet. But it will hopefully fix soon in one of the next releases. Very recently, like last week or so, we published our report about an investigation where we analyzed the security of so-called backend as a service providers, so this cloud stuff. And it was quite shocking. So we found like 56 million sensitive user data publicly available. If you're interested in this one, just look it up or ask me later. So this was quite shocking. But anyway, we're also working together with industry partners. For instance, we work together with McAfee, so antivirus companies. And together with them, we did a Korea threat investigation. So we were analyzing a malware targeting South Korea. And I will also give a demo on this, a live demo, so cross the fingers that the demo works. And you will see later on. So this is basically a wrap-up. So, I guess every one of you knows what this is. This is a Google Play. If you don't know this, so this is probably not the right place to be. And we have a lot of apps there, right? So you looked it up, I guess 1.5 million in the Play Store, and probably you develop one or even more, right? So you're developing whatever, some funny apps or also some sensitive apps, for instance, banking applications where you have some sensitive content in it. And probably you ask yourself about how easy is it to dismantle this app or how easy to reverse engineer the app. I don't say hacking because hacking is a bad word. So how easy is it to reverse engineer? So probably you ask yourself this. Also, one guy at Stack Overflow asked him this, which is very a good question. So he said, I'm planning to publish a new app, and I've heard that it's very easy to pirate an Android app. In other words, it is very easy to reverse engineer an Android app. So what can I do, right? So how can I secure my code? Or in other words, how can I protect my code in such a way that it is not so easy for a human to reverse engineer and to understand what's going on in your code? But he mentioned a very good point, and he said, I know that I can never be 100% secured. So you can never get 100% secure that no one understands your code. It's just a matter of time, how long an attacker takes to analyze the application, and time means money. So if you put a lot of protection mechanisms, so it takes him longer and probably he gives up. So he got a lot of replies from the community saying, use obfuscators. So there were mentioned a few. For instance, in the first talk today, we heard about DexGuard or ProGuard, or even more sophisticated ones. So he got a very good response. And still, I ask myself, is it still easy to dismantle the app, even if you apply obfuscation technique as DexGuard, for instance? And this is where our tool comes into play, the CodeInspect. This is a new binary analysis framework for Android and Java bytecode, so at the bytecode level. And yeah, it's basically a reverse engineering framework, which I will introduce now. Good, so before doing so we have to differentiate between the good and the bad guys. So both use reverse engineering, so the good guys, so the green droid, They're using reverse engineering in their daily business. For instance, malware researcher at antivirus companies, they have to manually look into the code to understand if this is malware or a virus, I say malware now, or not. But the bad guys as well, so they would like to get into your code and understand what you implemented, and if you, for whatever reason, save some credentials in the code, due to reverse engineering, they will extract the credentials. Well, we have seen this. Just to be clear now, so we are the good guys. And in the following, I will tackle the perspective from a manual, from a reverse engineer, from an antivirus company. So we will later see in the live demo where I basically do reverse engineering on a malware sample in order to figure out if this is malicious or not. In the next slides, it will be a bit boring, so I will explain about the framework and all that. You get a big picture, how powerful this tool is, and then the cool stuff comes, and I try to do a live demo on this malware sample. Good. So, our underlying framework of this CodeInspect tool is the SOOT framework. The SOOT framework, just look at the upper part, so it is able to read different input formats. For instance, the DEX file, the Java file, a class file, and APK. So these are only specific for Android now input formats. So you can see it's like a binary format and a source code format, and it converts it into an intermediate representation. It's called chimple. So I will explain this in the next slide, what chimple means. So it takes this chimple code as input, basically, and SOOT is now developed for 12 years, I guess. So there's a very big community behind it. It was already originally designed as a compiler optimization framework. So with a lot of algorithms in compiler construction, for instance, call graph algorithms. So if one method, if you have a method, an invoke method, and it calls another one, so you have a graph, basically an edge in your call graph, which is very useful for manual reverse engineering. It also has other sophisticated algorithms very well known in compiler construction, for instance, dead code elimination or constant string propagation, and so on and so forth. So basically everything is in this box. Another interesting part is code manipulation. So what you can do, basically you can add new statements to the code, you can remove new statements, or you can modify even statements based on this chimple language. And as you can see, there's a bidirectional way. So this means you can take an APK as input, instrument a new line, for instance, a logging line after send text message, and then it basically writes it back to the APK. Of course, you have to sign it again, but you have an APK which can then run on any device. This was a very rough overview about SOOT. I actually could talk about 1 or 2 days about this framework. I refer to the wiki page if you're interested in more details, and also write me an email or write an email to my colleagues, and we are more than helpful to support you or to help you. Good. So this was SOOT, very rough overview. Now I talk about this magic intermediate representation called chimple. So this is a code snippet taken from original malware. So I did not modify it, I just modified it a bit. And this is how chimple looks like. So chimple actually stands for Java but simple. And so this means it is very human readable. And for instance, this is a method called USB autorun attack. And as a parameter, it has the full type with the package name. And the body of this method can be separated basically into 3 sections. The first one are the declarations. So this means this $string is basically the variable name. While we try to give it a proper name, we're also working on other algorithms to give it a better name as the type. In the code section, for instance, in the first line, we have an assignment to the URL server is a field basically of the type string and in the class tools. And it gets assigned to $string. And then we have a static invoke method called download file, and it has various types, and it has parameters. This is the original code, so I apologize for this, but this was the password, this. But the interesting point here is that there's a constant string in it. But in the original code, it can be the case that the constant string is not placed directly into download file. It can be whatever defined at the upper layer of this method body, gets assigned to a variable, gets reassigned to another one, and this one actually is in download file, for instance. But as I said, so we rely on this SUT framework, and so therefore we take this constant string propagation mechanism and it automatically replaces this with the autorun inf constant string, for instance. And in the end, yeah, we have a return statement in all cases. So it is very convenient to read, I have to say. Students of us, it took them 15 minutes to understand it, since it is very good to read this code. There are other languages I know, but I prefer this one. Good, so I talked about SUT, I talked about chimple a bit, and now basically on top is CodeInspect. So CodeInspect relies on this SUT framework, on all the algorithms there, and it basically represents you this chimple intermediate representation of an app. And now I will talk about CodeInspect a bit. Always when I explain about CodeInspect, I say to some friends or to some other guys saying, so just imagine you're developing a new app. So what are you doing? For instance, you're using Eclipse or Android Studio or whatever. Let's stay to Eclipse now. So you define a new workspace, you define your project, you add some new classes, methods, you add some new code, blah, 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 blah. And at some point you think about, okay, let's refactor the stuff, do renaming. I would really like to use the search stuff from this IDE. And at some point you run the app and of course it crashes. So you want to figure out why does it crash. So what are you doing? You're debugging, right? You're debugging, or you use test cases as the previous talk said. And at some point you find it out, you're debugging or whatever, and then you fix the code. And now just think about for a moment, this is source code. And now replace this source code with this intermediate representation chimple. And this is basically what CodeInspect is. You can do all these fancy cool things, but on the intermediate representation, which is actually the bytecode. So more concrete, for the file explorer, for instance, instead of the source code, we have the chimple, the intermediate representation, human readable intermediate representation. The readable files, for instance, the layout files are in a binary format, so we convert it into a human readable format. And then another thing is this DDMS. It's a very convenient tool in Android. Well, you're probably all aware of this one. So when you're doing debugging and when you run the app, so you can send specific intents, for instance, initialize a phone call, send a text message, or change the location, whatever. And this is also possible within CodeInspect when you run the application or when you debug the application. For the editor part, well, you already have seen it, we have nice syntax highlighting. You can do code refactoring. This means you can do renaming, especially in cases when the app is obfuscated with, for instance, ProGuard or whatever. You can rename the package, the class, the field, the method, whatever. And another cool thing is the Java source enhancement. Remember what I said, that the SUT framework is able to read the source as well as the bytecode. So what we can do with this tool, we convert it into chimple, and then you can add your plain Java source code to it, and it gets compiled into the app. And if you call this source code within the original chimple code, for instance, it also gets executed. You will see this in the live demo. And then, well, we have the debugger I mentioned already, and code manipulation, so you can remove, add, comment out some code lines, and so on. So now for the plugins. So for the plugins section, basically in our research group, as already mentioned, other colleagues of mine, we are doing some research on static and dynamic code analysis. And the goal here is to put this knowledge into this tool via a plugin, for instance. So in cases of a data flow visualizer, for instance, so we have a tool called FlowDroid, which is a static data flow tracker. So what can you do with this data flow tracking thing? So for instance, if you're interested in data leaks in an application, so for instance, is my contact data sent via the internet, you can use a so-called taint analysis or data flow analysis, and we have one called FlowDroid, and we can visualize the flow if we detect one in this framework. Deobfuscators, so there was a question in the first talk about deobfuscation, especially for DexGuard. So DexGuard highly uses a reflective call and you don't see anything. We developed a novel technique combining static and dynamic code analysis, where we try to undo the reflective call to the original API call, even if it's highly obfuscated. We have a very high precision and recall for doing this, so it looks very good. And it's also in this framework. And then region detection, for instance, if you have emulator checks or routing checks, so we basically highlight these sections in the code that it is very easy for a human analyst to directly look at this code. Good. So let's get started, right? So what do we have to do? How many scripts do we have to run to get this done? None, actually. So two things what you have to do. You have to open this file, which is basically based on Eclipse or RCP platform. And then you do a right-click import APK, and you add the path of the APK. And that's it. And it automatically recompiles it and does everything for you. If you would like to debug it or do a dynamic analysis, basically, you can start any emulator or your device. It doesn't have to be modified, whatever. And as you do it at the source code, you get this screen, the pop-up. You choose your device, you set a breakpoint, and you can go on for debugging. So this is basically it. And yeah, now the cool part starts. So the real-world malware. So in December last year, so we, together with McAfee, we did a malware investigation. So we found a new malware that was targeting South Korea, or Korea. And basically what this malware did, it was basically, it took the hype of the interview movie, and it said, if you download, so with this app, you can download a free version of this new movie, which was not published yet. Of course not. What it did, it downloaded a malware, and the malware basically was a banking Trojan. So this means, well, you had to put in all your credentials, your data, whatever, and it stole all data. It also stole your incoming SMS, it canceled phone calls, so it had a lot of malicious stuff in it. So it was very interesting. But the bad thing here was like it affected 20,000 users within 2 months. So if, yeah, this was not cool. And yeah, so there are a lot more components in it, but I will, for that demo now, I picked one specific malicious component I will explain. So this malware basically, so you install the app on your phone, it expects an SMS from the bad guys. It had to have a specific format, you will see, and then the intercepting SMS activation component is activated. From that, if it received this SMS, the intercepting works, and if your friend or whatever sends you an SMS or a message, then they do two things. They first send it via HTTP to their server and via email. So by two channels. Of course, if you shut down the HTTP one, there is still the email one, and they still get the data via the email one. And this was the case. So HTTP was very easy. You can do network traffic sniffing, and then you see exactly, okay, this URL, so I shut down this server. But for the email one, we didn't know what is the account of this email. We knew that it was an SMTP connection, but we didn't know the credentials. And so we said, okay, let's have a try with CodeInspect and figure out what's going on. And this is what I will show now in the live demo. I hope that it works. So, yeah. Good. Probably I will move in a bit. Can everybody read this, or is it too small? That's is it okay? Yeah, okay. So this is basically CodeInspect. And what you do, you basically right-click, you do an import, and here we go. You could now CodeInspect import. As I mentioned, you can import the APK. If you have the APK on your local store, you can use it there. You can even plug in your phone, and it tries to extract the APK or import a jar and whatever. Then you click next. Then you add the path here, and you give it a project name. So every APK is basically a project. Then you finish, and it automatically then creates this new project here. It has basically, here we go, assets folder, lib folder, or resources folder. For instance, the layout, there's already one open, this cert password layout. So this was one layout they used. What you can do as you do it at Java source code level, you can now change the layout if you want. You add a new button, click save, and you have a new APK with this new layout. Well, you can double click on this one, and then you basically see the code here. You can change it again, and so on and so forth. I guess this is nothing new to you, but again, we are now at the bytecode level, not at the source code. Okay, so there are the sources. Again, I apologize. So this is their original naming of packages. So this is very common in malware, so that they use this verse. And there is basically whatever. If you open the main activity now, this is basically chimple code. Well, you don't have to understand this now, the code. It's just that it is. If you take like 10 minutes or 15 minutes, then you understand it. So, but it is very cool, and it's readable, and it has basically the types. So we are able to extract the types, and this is not a register-based intermediate representation. Okay, so let's go further. The Android manifest XML, well, nothing new to you. It has a lot of permissions, of course, since it is a malware. Does everything, basically. And well, what I wanted to show you that this is basically the launcher, or the main activity, and we have a hyperlink here, basically, and then you directly jump to this method. Here is the outline, so you can jump to methods on create, whatever on create is, so the method called here. Hold on a second. Here's the on create. Here's the on create. Due to resolution things. And then you do the search, for instance, search file. I just show you some things what you can do, but I guess it's clear. For instance, if you look for password. So it looks for password in the whole thing. Is there anything interesting? Yeah, for instance, here is a constant password. Well, it doesn't matter what this is now. It's not so interesting, but this is a password what they used. They did not obfuscate it, but anyway. So yeah, I just wanted to say, I used this malware sample because it's easier for you to follow. I could also take a highly obfuscated one, but then it's not so easy to follow this stuff. Yeah, so you can do everything. I guess this is clear. And then the interesting part is debugging. So for instance, I set a breakpoint into onCreate, which gets called first, so there's no application and so on, no content provider. This is the first method. And what do? So you basically, I started already an emulator, which should be somewhere. Here's my emulator. Yeah, here we go. It's here. So here's the emulator. I started this guy already. And yeah, when you do debugging, debug configuration, nothing special, just for completeness. Here, basically, you define a new app. Then you define the APK or your project, and it automatically tries to get the launchable activity. So we try to do it. If it's not the case, you can pick another one. Then for the target, and so on and so forth. And then you click debug. And I hope it works. Yeah. So now you see basically all the devices. In this case, I have only one. If you plug in a phone, blah, blah, blah. So you see more. So I use this one, which you have seen previously. And now it's installing the app there. And it's connecting the debugger. So yeah. It asked me, yeah, please change to the view. And here we go. Now, well, this is too tricky now. So here, again, you have the variables, the runtime value variables. You can change the runtime value if you want. You will see this. So here, all the runtime values so far. And now you can do really debugging. What do you want? So I do a single debugging now. I debug, whatever. And then I'm interested in what is this is-e method. I just click on it and I go into it and make it larger. And what they're doing here, this is very common in malware. So they try to figure out, do I run on an emulator or not? So there are different properties on an emulator which are unique for an emulator and not for a real device. There are more sophisticated checks, but these are easy ones. And they try to figure out, do I run on an emulator? Why are they doing this? They're doing this since usually a malware, you analyze the malware in an emulator due to various reasons. So they try to figure out, am I analyzed or not? If yes, I cancel it. And this is-e stands for is emulator. So, wait a second. So now I do a single debug over, and now we can see that set 0 is basically true, since I run on an emulator and one of the checks was successful. I could change this to false now if I want, then I do not run, but I wanted to show you what they're doing. So this is an if statement, for instance, if set 0 equals to true, go to label 3, so we have go-tos. We're also working on some other representation, and now it basically tries to exit it. So when I run this now, it's disconnected, it's not there anymore. So what can we do? So yeah, the only thing which is not so cool is this true. So what we're doing, we're commenting it out, I save it, and that's it. Oh yeah, it's already built. So now we are starting it again. Yeah, here you go. Choose the device, installing, and so on and so forth, connecting. Yeah, here we go. So again, I do a single debug stepping, I step, and now I step over it. So now I step over a code which was there originally. Just think about this in cases, well, we did not do it, but if you have a free version and in the Play Store, a trial version and a full version, yeah. No, we did not do this. So I continue here, whatever, and I run it now because we were interested in the fact, what is the username and the password, right? So I set already a breakpoint there, and you will see it, and it hits it. Yeah, so this was, so when you look for username, these guys did a very bad job, so they made it very easy for us to reverse engineer it, because if you look for username, so you get it here, and then you try to figure out what is it. And when I hover over this now, it gives me basically the email address of this account where the data was sent to. And there were a lot, 20,000 from one user, all SMS, all credentials, so it was cool. So the question now is, why is it so hard, or what did they do? Though this string is here, and there is a method called string user. So what is this? When I scroll down, this is a native code. So what they did, they hid the password and the account in native code. They obfuscated because native is harder to reverse engineer. So, but we don't care. We set a breakpoint. They can do whatever they want in native, and we get it. And this is basically it. While for the password, it's the same. So now I run it. So here's the password. Yeah, I can show it to you actually what they did. So they stored it into a shared. So they read it basically from the native part, and then they store it into shared preferences. And when they send the email, they read from the shared preferences the credentials, and then they send it. And yeah. So good. So now it's running the app, and it expects an incoming SMS, what I said. So I can do this with this DDMS one, for instance. Yeah. So this is my emulator, and now I send the incoming number, whatever, 4242. Hi, DroidCon. So I send. I already put a breakpoint to the on receiver, so you should receive it. But now nothing happens. I click on it, nothing happens. Yeah. This is okay. Yes, now it happened. So this was not intent. I wanted to show you something else, actually. But anyway, so it works. Second. Yeah. So this is actually wanted to show you that you have to send a specific command first. And then this intercepting SMS is activated, and then you send it. But I did this previously. I already sent this specific command. Anyway, so now I set a breakpoint. Remember, there were two channels, one HTTP and the other email. I set two breakpoints. So one is the mail send. So what are they doing? So this is the method now. This is the subject of the method. This is the phone number. And this was basically the content of this. So whatever you got an email from 4242, it was hi DroidCon, it was the timestamp, and this was basically the username, and the other one was the password. And then they had two threads, so one for the SMS and one for the HTTP one. Here we go, there should be one. Yeah. Here is the post JSON request, so they do the same, just for completeness. They do the same. And they steal the data and they send it to this URL. Well, you can see it also here. As you can also change it if you want. And yeah, so I send it here, and it was basically a JSON one. And they put into JSON the same data as they sent via SMS. Content, blah, 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 mobile. So this is very easy now. You can see you can debug the stuff. And it's also for you interesting. So with this tool, one could debug your code and could understand what you're doing, could understand the algorithm. Since you can change it, you can single debug it, you can even remove some code. And now I show you another bad thing for you, but cool for the malware reverse engineer. You can now add a Java source code, what I said. So we have a folder called Java sources. I already added a new, you can add a new package name, whatever, DETU Darmstadt, and a class called test. while this is probably not the right way to do an alert dialog, you're probably much better than I am. But anyway, so this is just for testing. It is a test method. You can, whatever, I basically give it an emulator if the emulator is true or false, and please show the icon. And what I do, create an alleviate, and here you can see what you have auto-completion. So I did not show this for chimple, but you can auto-completion. Whatever, hello, I'm in Java. I can even change this to whatever, droid, gone to 15. No, 15. I save it, and that's basically it. It is compile. And yeah, and then there's the emulator. If the emulator detected, okay. And if this show is show, it shows the one. So now I set a breakpoint here. And I will show you where in the main activity, where this method gets called. So I put it a static invoke method call to this de_to_Darmstadt test, which is basically this class, and the test method, and containing the context of this one. Set0 was the M&M emulator or not, and false basically show it, and I now set it to true, please show it. I save it, it is done, that's it. Yeah, so now let's debug this guy. Oh yeah, I forgot. So you don't have to write this static invoke if you want. You can do a right click, where is it, add Java call, and then you can pick the Java method which you would like to invoke, and we create a default or a stub invoke method call for you. So now let's debug it again. A thread. Yeah, well, we all know this already. Yes, I want. Again, I do single stepping, single again, and now I do a single step and see what happens. So now we change, and now we're at the source code level, and we can change the source code as well. So for instance, set title, emulator, whatever. I can change now the emulator if you want, because I didn't show this. Whatever, droidcon again. Yeah, droidcon. And now, basically, the emulator message, if I hover over it, is this one and not the one. Well, you got it. And I check, I run again. So I switch to the emulator now. You don't see anything, so this malware is also, you don't see much. Actually just invokes the Play Store, that's it, and then they do the malicious stuff behind. I run it now. Yeah, we are there. I set a breakpoint there, okay. And I run it. Yeah, there should be the other breakpoint. Yeah, this one. And I run it. And here we go. Here is the message with the modification of the droidcon to 15 and this one. So I can add new code into any application, and I do not have to write it into chimple, which is not so convenient. I can write it into Java source code. So this means for the bad guys, this is very convenient because they can take a very popular app, for instance, Facebook or whatever, and they can basically piggyback it with the malicious code written in Java source code, save it, sign it, that's it. But for the, we are, again, not the bad guys, we are the good guys. So for the good guys, it is very good if you have an encrypted method call in the malware, which basically encrypts something. You have to write a decryption method. So you can write this in Java source code, and you can even debug if I implement it in the right way, which is very convenient. So. Okay, oh yeah, one more thing I want to show. This was also very funny. So this exception is not an exception from CodeInspect. This is an exception from the malware, since their implementation is not so good. So there is no exception handling, really. So actually, I even had to fix one line because they wanted to actually intercept only incoming calls which are not a phone number in your address book. But what they did to whatever, I saw the if, but they did the wrong if, so they canceled all incoming calls. So I basically fixed it for them, but yeah. But this is sad. So, but they come better and better and better, and yeah. Anyway, so good. Let's continue. Talk. Oh no, not this one. Live demo. So this was the live demo. What are the future steps here? So we are currently implementing new plugins which are under development. So this is basically what the plugin, well, I was not able to show you the plugins, just the basic framework, but new plugins based besides this data flow tracker and the deobfuscator and some others. So new plugins are under development, which are based on our research, which we are doing. And there should be also a possibility that you, as an analyst, can easily add your own analysis into this framework, which then can use algorithm from suit or whatever. For instance, if you say whatever, I have the best pattern, malware, algorithm, whatever, I would like to use CodeInspect, implement this, load in an APK and check if this is malicious or not. You should be able to do this, which is based on a plugin now. So we try to give a stub of Eclipse plugin where you can easily write your own analysis in CodeInspect. Good. So how do I get this tool? We are currently at the testing phase. But it's very stable though. So many researchers from all over the world, mostly like security analysts, but also normal developers, using it, and we got very good feedback. So this is a very stable version right now, but still we're in the testing phase. We try to commercialize it, but this will take some time. But currently we are in the testing phase, and we are giving out free test licenses, as many as you want. Just write me an email. The email will be at the last slide, and you get one. It would be great if you could tell us if it is whatever good or... Well, we know we have some issues again, but we are working hard on this to make it a good and a stable and a new reverse engineering tool for Android. So let's sum up my talk. I talked about the initial problem about the fact that a lot of guys are try to obfuscate the code and use whatever different techniques, right, which you all know. But the big question is it possible to reverse engineer the app easily? We come up with a tool called CodeInspect, which at least for the Java bytecode or the Android bytecode part, gives you an easier way to do this and an easier way to understand the code. It relies on the chimple intermediate representation, which is very human readable, and the SUT framework with all the algorithms and all the stuff. And we support currently different plugins. More will come later. And this brings me to the end of my talk. Thank you very much for your attention, and I will be outside, so if you have any more questions, please come. I'm more than welcome to talk to you. Thanks.